Have you ever pondered upon the enigma that is the universe? Ever wondered how a black hole, one of the most mysterious entities in the cosmos, is formed? Well, it all starts with the gravitational collapse of a massive star. Imagine a star much like our sun, but significantly more massive. This star is in a constant battle, balancing the forces within itself. On one hand, there's the inward pull of gravity trying to squeeze the star into the smallest, densest point possible. On the other hand, the energy released by nuclear reactions in the star's core pushes outward, resisting this gravitational compression. Over time, the star uses up its nuclear fuel. With the fuel gone, the star loses the energy needed to resist gravity. The gravitational forces, unopposed, force the star's core to collapse under its own weight. This collapse results in an extremely dense, compact region known as a singularity. Yes, a point in space where density and gravity become infinite. Simultaneously, as the core collapses, the outer layers of the star are violently expelled into space. This dramatic expulsion creates a brilliant explosion known as a supernova, outshining all other stars in its galaxy for a brief period. But the spectacle doesn't end there. If the remaining mass after the explosion exceeds a critical value, something known as the Chandrasekhar limit, the gravitational forces become so intense that nothing, not even light, can escape from the region around the singularity. This is the birth of a black hole, a region of space-time where gravity is so strong that nothing, not even particles or electromagnetic radiation such as light, can escape from it. Black holes are not a one-size-fits-all phenomenon. They come in different sizes. Stellar mass black holes are formed from collapsing stars, much like the one we just discussed. Then there are the supermassive black holes found at the centers of galaxies. These giants are formed through the accumulation of mass over cosmic time. So, to summarize, black holes are formed from the gravitational collapse of a massive star. When the star exhausts its nuclear fuel, it can no longer support itself against the pull of gravity. The ensuing core collapse in supernova, if the remaining mass exceeds the Chandrasekhar limit, leads to the formation of a black hole. The size of the black hole depends on the mass of the original star, or the accumulation of mass over time. Understanding the formation of black holes offers a glimpse into the intriguing and mysterious nature of these cosmic entities. They may be invisible, but their impact on the universe is anything but. Through their formation, we gain insight into the complex and fascinating dynamics of our universe.